Have you ever wondered what the universe hides beyond what we can see? From spirals and rings to invisible giants, galaxies are full of mysteries. Today, we're diving into 100 mind-blowing facts about galaxies you can't even imagine. Get ready to explore cosmic wonders that stretch across billions of light years. Chapter 1. Galaxies come in countless shapes and sizes, from elegant spirals to chaotic irregulars. Our Milky Way is a barred spiral, stretching over 100,000 light years. Imagine billions of stars swirling together, each with its own story. Some galaxies collide, merging into spectacular cosmic dances that reshape the universe. Even black holes at their centers quietly influence these majestic structures, pulling stars in invisible gravitational choreography. Chapter 2. Some galaxies are massive, holding trillions of stars, while others are tiny, with just a few thousand. The Andromeda Galaxy, our nearest neighbor, will one day collide with the Milky Way, creating a cosmic fireworks show over billions of years. Stars born during these collisions shine brighter, creating new clusters and leaving trails of gas and dust that hint at a galaxy's violent past. Chapter 3. Elliptical galaxies look smooth and featureless, but hide secrets inside. Most are older, full of ancient stars, and contain very little gas for new star formation. These galaxies grow by merging with others, quietly expanding over billions of years. Deep in their centers, supermassive black holes can consume anything that drifts too close, sometimes launching jets of energy visible across the cosmos. Chapter 4. Galaxies aren't isolated. They often cluster together, bound by gravity. These clusters can contain thousands of galaxies, all interacting and sometimes merging. Dark matter, invisible but massive, holds these clusters together, shaping the universe at a scale we barely perceive. Light from distant galaxies stretches as the universe expands, giving astronomers clues about their distance and the universe's mysterious history. Chapter 5. Some galaxies are cosmic ghosts, fading into near invisibility. Ultra-diffuse galaxies can be as large as the Milky Way, but contain only a fraction of its stars. They float silently in space, surrounded by dark matter halos that keep them from falling apart. Studying them challenges what we know about how galaxies form and survive in the vast emptiness of the universe. Chapter 6. Galactic collisions are both destructive and creative. As two galaxies merge, stars rarely collide due to vast distances, but gas clouds crash together, sparking starbursts. These events can feed supermassive black holes, producing quasars brighter than whole galaxies. Over time, the remnants settle into new shapes, forever altering the structure of the universe and leaving astronomers in awe of these cosmic transformations. Chapter 7. Spiral galaxies like the Milky Way have stunning arms wrapping around a dense core. Stars, gas, and dust orbit the center in a delicate balance, forming star-forming regions. Nebulae within these arms glow as new stars ignite. Gravity subtly twists these arms, maintaining their shape over billions of years. Observing them gives clues about stellar life cycles and the rhythm of galactic evolution. Chapter 8. Galaxies sometimes eject material in spectacular ways. Active galactic nuclei can launch jets of plasma across thousands of light years. These outflows can influence star formation, sculpt interstellar gas, and even quench new stars from forming in certain regions. Observing these cosmic geysers reveals the delicate balance between creation and destruction that governs galaxies across the universe. Chapter 9. Dwarf galaxies play a surprisingly crucial role. Though small, they often orbit larger galaxies like satellites. Their gravitational interactions can trigger waves of star formation in their hosts, creating ripples across spiral arms. Some dwarfs are remnants of ancient collisions, holding clues to the Milky Way's own chaotic history. Even tiny galaxies can leave a massive mark on the cosmic stage. Chapter 10. Galaxies glow in colors invisible to human eyes. Infrared, ultraviolet, and X-ray observations reveal hidden star-forming regions and black hole activity. Cosmic dust absorbs visible light but re-emits it at other wavelengths, uncovering layers of complexity. Each wavelength tells a different story, showing astronomers that what we see isn't always the whole truth. The universe is richer than the eye can perceive. Chapter 11. Some galaxies spin at incredible speeds, with stars orbiting the center at hundreds of kilometers per second. This rotation is influenced by both visible matter and invisible dark matter, which dominates the galaxy's mass. Without it, stars at the edges would drift into space. Studying galactic rotation curves helped scientists discover dark matter, revealing that most of the universe is hidden from view. Chapter 12. Ring galaxies are cosmic rarities, often formed by collisions. A smaller galaxy can slam through a larger one, creating a rippling wave of star formation in a circular pattern. These rings glow brightly, hosting young, massive stars. Observing them is like watching a cosmic splash frozen in time. They remind us that even destructive events can create beauty on a galactic scale. Chapter 13. Some galaxies are chaotic and irregular, lacking structure. Often smaller or disrupted by collisions, they contain massive star-forming regions and scattered clusters. Despite their messy appearance, these galaxies are laboratories for studying how stars form under extreme conditions. Their irregular shapes show that not every galaxy follows the rules of spirals or ellipticals, revealing the universe's variety and unpredictability. Chapter 14. Galactic halos are invisible clouds of stars and dark matter surrounding galaxies. They stretch far beyond the visible disk, sometimes 10 times its size. Halo stars are ancient, providing a window into a galaxy's past. Dark matter in halos governs how galaxies rotate and interact, showing that what we see is only a fraction of the cosmic story. Chapter 15. Some galaxies glow with intense activity, called starburst galaxies. Collisions or gravitational forces compress gas, igniting rapid star formation. These galaxies can produce hundreds of new stars every year. Supernova explosions from these young stars inject energy and metals into space, shaping future generations. Starbursts are a glimpse into the raw power of cosmic creation, chaotic yet mesmerizing. Chapter 16. Galaxies host supermassive black holes millions to billions of times the sun's mass. These giants sit at centers, quietly influencing star orbits and gas clouds. When actively feeding, they emit powerful radiation as matter accelerates toward the event horizon. Even though we can't see them directly, their presence shapes galaxy evolution and sparks some of the universe's most energetic phenomena. Chapter 17. Some galaxies appear completely dark, detectable only through their gravitational effects. Dark galaxies are rich in gas but lack stars, making them nearly invisible. Their existence challenges traditional ideas of galaxy formation and forces astronomers to rethink the balance between visible and dark matter. Invisible doesn't mean unimportant. These hidden galaxies silently sculpt cosmic landscapes. Chapter 18. Galaxy mergers often trigger unusual structures, like tidal tails and bridges. Streams of stars stretch across space, connecting colliding galaxies. These cosmic remnants tell the story of violent interactions that last millions of years. Observing them is like reading a history book written in starlight, revealing how galaxies grow, evolve, and sometimes cannibalize their neighbors. Chapter 19. Some galaxies host thousands of globular clusters, spherical collections of old stars orbiting the galaxy's halo. These clusters are among the oldest objects in the universe, dating back over 12 billion years. They act as time capsules, preserving clues about early galaxy formation. Studying them is like peering into the universe's deep past, where the first stars quietly shaped the cosmos. Chapter 20. Galaxies sometimes form spectacular streams of gas and stars called filaments. These cosmic threads connect clusters across the universe, forming a vast, cosmic web. Matter flows along these filaments, feeding galaxies and guiding their growth. The universe is structured like a delicate spider web on a colossal scale, revealing patterns far beyond what the naked eye can see, where galaxies trace the invisible threads of gravity. Chapter 21. Some galaxies glow in X-rays, invisible to the human eye. These high-energy emissions often come from hot gas, supernova remnants, or active black holes. Observing them reveals violent processes hidden in visible light. X-ray astronomy allows us to witness cosmic fireworks, where matter is heated to millions of degrees, showing that galaxies are far more energetic and dynamic than they appear. Chapter 22. Barred spiral galaxies, like our Milky Way, have a central bar of stars stretching across the core. This bar funnels gas toward the center, fueling star formation and feeding the supermassive black hole. Bars can evolve over time, reshaping the galaxy's structure. They are a subtle engine controlling a galaxy's inner life, quietly orchestrating how stars and gas flow in a cosmic rhythm. Chapter 23. Some galaxies spin in ways that defy expectations. Certain dwarf galaxies rotate in reverse or are misaligned with their parent galaxy. These anomalies hint at past interactions, mergers, or gravitational tugs. Observing them teaches astronomers that galaxies are not always orderly. They are living, evolving systems shaped by collisions, gravity, and the chaotic history of the universe. Chapter 24. Galaxies can host colossal clouds of gas, sometimes spanning tens of thousands of light years. These clouds fuel star formation, creating stellar nurseries where young, massive stars ignite. Ultraviolet light from newborn stars illuminates the gas, producing stunning nebulae. These regions are both beautiful and violent, as stellar winds and supernovae shape the gas, constantly reshaping the galaxy's appearance. Chapter 25. Some galaxies are quenched, meaning they've stopped forming new stars. Often older and elliptical, they exhausted or expelled their gas. Observing them reveals how galaxies age and evolve. Even in silence, they hold secrets, ancient stars, black holes, and chemical fingerprints. Quenched galaxies remind us that not every galaxy is a bustling factory. Some quietly fade into cosmic maturity. Chapter 26. Galaxies can collide with unseen dark matter halos, which influence their motion and shape. Though invisible, dark matter acts like a cosmic skeleton, guiding galaxy growth and clustering. These interactions can warp galactic disks, trigger star formation, or slow collisions. Understanding dark matter's role is crucial. Without it, the universe's large-scale structure would look completely different. Chapter 27. Some galaxies exhibit polar rings, circular bands of stars and gas orbiting perpendicular to the main galaxy. These rare structures form when one galaxy captures material from another. Polar rings provide unique insight into galaxy dynamics and interactions. Observing them is like seeing cosmic choreography from a different angle, where gravity sculpts stars into shapes that defy expectations. Chapter 28. Galaxies can host intense bursts of radio waves. Radio galaxies often feature enormous jets of plasma emitted from supermassive black holes. These jets travel thousands of light years, influencing surrounding gas and triggering or suppressing star formation. Radio observations reveal hidden energy and structure, reminding us that galaxies are far more active than optical light alone can show. Chapter 29. Lenticular galaxies bridge the gap between spirals and ellipticals. They have disks like spirals but little gas or star formation, appearing smooth like ellipticals. Lenticulars are often the product of mergers, stripping away gas and leaving a quiet, stable galaxy. Studying them shows how galaxies can transition between types over billions of years, evolving through both violence and quiet stability. Chapter 30. Some galaxies host massive star clusters, each containing hundreds of thousands of stars. These clusters orbit their galaxy's halo and often survive billions of years. They are relics of ancient times, preserving the chemical makeup of the early universe. Observing them is like traveling back in time, witnessing the first sparks of star formation that shaped entire galaxies. Chapter 31. Some galaxies are shaped by powerful winds from massive stars. These stellar winds push gas outward, creating bubbles and cavities. Over time, this reshapes the galaxy, triggering new star formation in some regions while suppressing it in others. It's a delicate balance between creation and destruction, showing that even tiny stars collectively influence the destiny of entire galaxies. Chapter 32. Certain galaxies appear stretched, forming elongated shapes called tidal dwarfs. They emerge from interactions and collisions between larger galaxies. Despite their size, they can host active star-forming regions. These distorted galaxies demonstrate that cosmic violence often sparks creativity, and even small galaxies can bear the scars and beauty of galactic encounters. Chapter 33. Galaxies often form along massive filaments in the cosmic web. These structures channel gas and dark matter into galaxies, feeding growth over billions of years. Filaments connect clusters across unimaginable distances, creating a network that governs the universe's architecture. Observing galaxies in this context reveals that no galaxy exists in isolation. They are all part of a vast, interconnected cosmos. Chapter 34. Some galaxies shine in ultraviolet light, invisible to our eyes. Young, massive stars emit this radiation, revealing stellar nurseries hidden behind dust. UV observations uncover rapid star formation and hot, energetic regions. Without these tools, we'd miss much of a galaxy's activity. These invisible glows remind us that the universe has layers waiting to be explored beyond human sight. Chapter 35. Certain galaxies host supernova factories. In starburst regions, massive stars burn fast and explode violently. Each supernova spreads heavy elements, seeding future generations of stars and planets. These explosions sculpt gas clouds, leaving remnants visible for thousands of years. They are dramatic reminders that galaxies are dynamic, ever-changing systems where death and creation coexist. Chapter 36. Some galaxies host dual or even triple nuclei, remnants of past mergers. These cores can contain supermassive black holes, each influencing surrounding stars and gas. Over time, these black holes may merge, releasing gravitational waves that ripple through the universe. Observing multinuclei galaxies provides insight into how collisions shape structure and the hidden drama in galactic centers. Chapter 37. Ultra-compact dwarf galaxies are tiny but densely packed with stars. Despite their size, they can outshine entire star clusters. They often orbit larger galaxies, carrying clues about ancient mergers. Studying them helps astronomers understand the diversity of galaxy types and how even small systems play a role in the universe's grand evolution. Chapter 38. Some galaxies are almost entirely dark, detected only by the gravitational lensing they produce. Light from distant galaxies bends around them, revealing their hidden mass. These invisible galaxies show that the universe is full of hidden giants. Studying them uncovers the unseen scaffolding holding galaxies and clusters together. Chapter 39. Galaxies sometimes host massive streams of stars, left behind by disrupted satellites. These streams trace past interactions and mergers, acting as cosmic footprints. They reveal the Milky Way's own violent past and show how galaxies grow by consuming smaller companions. Each stream tells a story written in starlight, a testament to the universe's relentless motion and change. Chapter 40. Some galaxies rotate so fast that their spiral arms twist tightly. This affects star formation, concentrating gas in certain regions and leaving others sparse. Observing rotation patterns helps astronomers understand galaxy mass, distribution, and dark matter influence. These whirling giants show that even the spin of a galaxy can reveal the invisible forces shaping the cosmos. Chapter 41. Some galaxies host rings of young stars orbiting their cores, formed from past collisions or accreted gas. These rings shine brightly in blue, indicating hot, massive stars. Observing them reveals how galaxies recycle material and continue forming stars long after their initial creation. Cosmic collisions leave lasting, beautiful imprints, shaping galaxies in ways both subtle and spectacular. Chapter 42. Certain galaxies are entirely devoid of spiral arms, forming smooth elliptical shapes. These galaxies often contain old stars and little gas, appearing calm and featureless. Yet within their cores, supermassive black holes silently influence their surroundings. Their apparent simplicity hides a complex history of mergers, interactions, and cosmic evolution spanning billions of years. Chapter 43. Some galaxies host giant molecular clouds, the raw material for star formation. These clouds span hundreds of light years and contain enough gas to birth millions of stars. Stellar winds, radiation, and supernovae constantly reshape them, making star formation a chaotic and unpredictable process. Studying these clouds gives insight into how galaxies build their stellar populations over time. Chapter 44. Galactic cannibalism is common. Large galaxies consume smaller companions. The smaller galaxies' stars are stretched into tidal streams, slowly merging into the host. Over billions of years, these interactions grow galaxies and fuel their central black holes. Even the Milky Way is a predator, quietly devouring dwarf galaxies while reshaping its structure. Chapter 45. Some galaxies shine with intense infrared light, invisible to the human eye. This radiation comes from dust heated by young stars or active cores. Infrared observations reveal hidden star-forming regions and energetic activity obscured in visible light. Galaxies are layered systems, where invisible energy often drives visible transformation, giving astronomers a fuller picture of cosmic life. Chapter 46. Certain galaxies exhibit warped disks, likely caused by gravitational interactions or past mergers. These distortions affect star and gas distribution, influencing star formation patterns. Warped galaxies show that cosmic structures are rarely perfect. Gravity constantly molds them into diverse and fascinating shapes over billions of years. Chapter 47. Some galaxies rotate counter to expectations, with stars orbiting opposite to the main disk. These counter-rotating systems often result from accreted gas or mergers. Studying them helps astronomers understand angular momentum, galaxy formation, and the chaotic history hidden in otherwise serene cosmic structures. These unexpected motions reveal the universe's complexity. Chapter 48. Galaxies can host luminous star clusters in their outskirts, relics of ancient star formation. These clusters orbit the galaxy's halo, often surviving billions of years. Their stars preserve chemical fingerprints of the early universe, offering a window into conditions billions of years ago. Even in small clusters, the history of galaxies is written in starlight. Chapter 49. Some galaxies host massive voids, regions with very few stars or gas. These cosmic gaps are caused by gravitational interactions or energetic outflows. Observing voids helps astronomers map the distribution of matter, visible and invisible. Even emptiness has structure, showing that galaxies live in a universe shaped by forces beyond our sight. Chapter 50. Certain galaxies glow brightly in radio waves, tracing jets from central black holes. These jets travel thousands of light years, influencing surrounding gas and even star formation. Radio observations reveal hidden energy and activity, showing galaxies as dynamic systems far beyond what visible light suggests. Their radio glow uncovers a universe alive with invisible motion and power. Chapter 51. Some galaxies host enormous black hole-driven outflows that push gas far into space. These winds can halt star formation, shaping the galaxy's future. Observing them reveals a delicate balance between feeding black holes and sustaining new stars. Galaxies are not passive. They are sculpted by both creation and destruction, driven by forces invisible yet immensely powerful. Chapter 52. Certain galaxies are packed with globular clusters, spherical groups of ancient stars orbiting their halos. Each cluster is a time capsule, preserving chemical traces from the universe's early epochs. Studying them uncovers clues about galaxy formation and evolution, showing that even seemingly minor structures hold deep cosmic secrets that span billions of years. Chapter 53. Some galaxies have polar rings, stars and gas orbiting perpendicular to the main disk. These rare structures often result from mergers or material capture. Observing them reveals galaxy dynamics in unusual orientations, highlighting that gravity molds stars into unexpected shapes. Polar rings are a reminder that the universe constantly surprises us with its variety and elegance. Chapter 54. Galaxies sometimes collide, forming spectacular tidal tales of stars and gas. These streams trace the gravitational dance of merging galaxies, lasting millions of years. Tidal features reveal past encounters, shaping future star formation. Observing these tales is like reading a galaxy's biography, written in streams of starlight stretching across the cosmos. Chapter 55. Some galaxies shine in ultraviolet light, revealing massive young stars invisible in normal light. UV observations uncover hidden starburst regions and energetic activity. These glowing nurseries show that galaxies are constantly renewing themselves, creating cycles of birth and transformation. The universe's energy often hides behind wavelengths our eyes cannot perceive. Chapter 56. Certain galaxies appear diffuse, with stars spread thinly over vast areas. Ultra-diffuse galaxies can be as large as the Milky Way, yet contain far fewer stars. They challenge our understanding of galaxy formation, showing that size does not always mean mass. These faint giants reveal a universe more diverse than appearances suggest. Chapter 57. Galactic rotation varies across types. Spiral galaxies often rotate rapidly, holding stars in neat orbits, while ellipticals spin slowly. Rotation curves reveal dark matter's hidden influence, keeping stars bound at the edges. Studying this motion uncovers the invisible scaffolding that shapes every galaxy, showing that what we see is only part of the story. Chapter 58. Some galaxies host rings of gas and stars, often formed after collisions or material capture. These rings can ignite bursts of star formation, glowing brightly in blue light. Ring galaxies are cosmic snapshots of interaction, showing that even violent events can produce patterns of beauty and order across vast scales. Chapter 59. Certain dwarf galaxies orbit larger hosts like satellites, interacting gravitationally. These small companions can trigger waves of star formation in the main galaxy. Even tiny galaxies leave a mark, influencing structure and evolution. Studying them uncovers the subtle but powerful forces shaping galaxies across the universe, where size does not equal importance. Chapter 60. Galaxies often exist in clusters, groups bound by gravity. Within these clusters, galaxies interact, collide, and merge over billions of years. Dark matter binds them together, shaping cluster structure. Observing galaxy clusters reveals how large-scale cosmic architecture emerges, showing that every galaxy is part of a vast, interconnected web across the universe. Chapter 61. Some galaxies host supermassive black holes millions or billions of times the sun's mass. Even when quiet, they shape star orbits and gas motion. When active, they emit intense radiation, forming quasars visible across billions of light years. These black holes quietly govern galaxy evolution, proving that invisible forces often control the fate of entire cosmic cities. Chapter 62. Certain galaxies glow in infrared light, revealing regions obscured by dust. Young stars heat surrounding gas and dust, producing radiant emission. Infrared astronomy uncovers hidden activity invisible in optical light. These galaxies remind us that appearances can be deceiving. The universe often hides its most energetic processes behind veils of cosmic dust. Chapter 63. Some galaxies rotate in unusual patterns, with stars moving counter to the main disk. These counter-rotations result from mergers or gas accretion. Studying them reveals chaotic past interactions and the complex mechanics governing galaxy evolution. Even serene-looking galaxies may hide a turbulent history, shaped by collisions and cosmic forces over billions of years. Chapter 64. Galactic halos extend far beyond visible disks, composed of dark matter and ancient stars. They influence rotation, structure, and interaction with other galaxies. Studying halo stars provides insight into a galaxy's early life. Invisible yet powerful, halos demonstrate that the universe has layers beyond our sight, silently shaping galaxies over eons. Chapter 65. Some galaxies are starburst galaxies, forming stars at extraordinary rates. Collisions or gas compression trigger rapid formation, creating clusters of massive, short-lived stars. Supernovae from these stars reshape the galaxy, enriching gas with heavy elements. Starburst galaxies show that creation and destruction coexist, making galaxies dynamic, ever-changing systems. Chapter 66. Certain galaxies exhibit warped disks due to gravitational interactions. These distortions affect star and gas distribution, influencing formation patterns. Warped galaxies demonstrate that cosmic structures are rarely perfect. Gravity constantly molds them into diverse, fascinating shapes over billions of years, revealing the universe's constant evolution. Chapter 67. Galaxies sometimes host luminous streams of stars, remnants of disrupted satellites. These stellar rivers trace past interactions, showing how galaxies grow by absorbing companions. Each stream is a historical record, written in starlight, revealing the universe's ongoing cycles of destruction and renewal across cosmic time. Chapter 68. Some galaxies shine in X-rays, revealing violent activity from hot gas, supernovae, or black holes. High-energy emissions uncover processes hidden from optical view, showing that galaxies are far more energetic than they appear. X-ray observations give astronomers a deeper understanding of the hidden life of these cosmic systems. Chapter 69. Certain galaxies host ultra-compact dwarfs, tiny but dense collections of stars. They orbit larger galaxies and are often relics of ancient mergers. Despite their small size, they carry vital clues about galaxy formation, revealing the diversity and history of the universe on both large and small scales. Chapter 70. Some galaxies glow with massive radio jets from central black holes. These jets travel thousands of light years, influencing gas and star formation. Observing them in radio reveals hidden power shaping the galaxy. Even galaxies that appear calm in visible light may harbor energetic forces driving their evolution from within. Chapter 71. Some galaxies host dual or multiple nuclei, remnants of past mergers. Each core may contain a supermassive black hole, slowly orbiting or merging over time. Observing these systems helps astronomers understand galaxy evolution and the role of collisions. These hidden centers reveal the drama happening in galaxies' hearts, often invisible to normal light, but shaping their destiny. Chapter 72. Certain galaxies are ultra-diffuse, with stars spread thinly over enormous areas. Despite their size, they contain far fewer stars than expected. Their survival is attributed to massive dark matter halos holding them together. These ghostly giants challenge assumptions about galaxy formation, showing that the universe is full of hidden, mysterious structures. Chapter 73. Some galaxies exhibit rings of stars and gas, often formed after collisions or tidal interactions. These rings ignite bursts of star formation and glow brilliantly in blue light. Ring galaxies are cosmic snapshots of interaction, demonstrating how violent events can produce elegant and unexpected structures across space. Chapter 74. Galaxies sometimes eject material in powerful outflows driven by black holes or starbursts. These winds can regulate star formation, shape gas distribution, and enrich surrounding space with heavy elements. Observing them shows that galaxies are not isolated. They interact dynamically with their environments, constantly reshaping themselves and their surroundings. Chapter 75. Certain dwarf galaxies orbit larger hosts, influencing spiral arms and triggering star formation waves. Though small, their gravitational effects leave lasting marks. Studying these companions helps astronomers understand how galaxies interact, grow, and evolve over billions of years. Even the tiniest galaxies can have outsized cosmic influence. Chapter 76. Some galaxies rotate at extreme speeds, with stars orbiting hundreds of kilometers per second. Dark matter is essential to maintain stability, preventing stars from flying away. Rotation curves reveal this invisible mass, offering insight into the unseen forces shaping the universe. Even motion itself tells a hidden story about galaxies. Chapter 77. Galaxies can host giant molecular clouds spanning hundreds of light years. These clouds are stellar nurseries, forming millions of stars over time. Radiation, winds, and supernovae continuously sculpt them, creating a chaotic yet beautiful cycle of birth and transformation. Galaxies are living systems, constantly reshaping themselves from within. Chapter 78. Some galaxies shine brightly in ultraviolet light, revealing regions of rapid star formation. UV observations uncover energetic processes obscured by dust in visible light. These glowing nurseries show that galaxies are ever-renewing, with young stars constantly emerging and shaping their surroundings, keeping the cosmic story in perpetual motion. Chapter 79. Certain galaxies host massive star clusters orbiting their halos. These clusters are ancient relics, preserving chemical signatures from the early universe. Observing them provides clues about a galaxy's formation history. Even small, isolated clusters carry stories billions of years old, connecting the present to the universe's deep past. Chapter 80. Galaxies often reside in clusters, where gravity binds hundreds or thousands together. Interactions, mergers, and dark matter halos shape their evolution. Studying clusters reveals the universe's large-scale structure, showing that every galaxy is part of an interconnected web. Clusters are cosmic cities where galaxies interact, collide, and grow over billions of years. Chapter 81. Some galaxies host supermassive black holes quietly influencing stars and gas. When active, they emit intense radiation, forming quasars visible across billions of light years. These cosmic engines control star formation and shape their galaxy's evolution. Even invisible forces can govern entire galaxies, proving that much of the universe's power lies hidden at the core. Chapter 82. Certain galaxies glow in infrared, revealing star-forming regions hidden behind dust. Young stars heat surrounding gas, emitting radiant energy undetectable in visible light. Infrared observations uncover activity invisible to the naked eye. These galaxies remind us that appearances can be deceptive, and the universe constantly hides its most energetic processes in plain sight. Chapter 83. Some galaxies rotate in unexpected patterns, with stars moving opposite the main disk. These counter-rotating systems hint at past mergers or gas accretion. Studying them reveals chaotic histories hidden beneath serene appearances. Even galaxies that seem calm may harbor secrets of turbulence, collisions, and cosmic forces shaping their structure over billions of years. Chapter 84. Galactic halos stretch far beyond visible disks, composed of ancient stars and dark matter. They influence rotation, structure, and interaction with other galaxies. Studying halo stars provides insight into a galaxy's early life. Invisible but powerful, halos demonstrate that unseen forces shape galaxies over cosmic time. Chapter 85. Some galaxies experience starbursts, forming stars at extraordinary rates. Compressed gas and collisions trigger rapid creation, producing clusters of massive, short-lived stars. Supernovae from these stars reshape the galaxy, enriching gas with heavy elements. Starburst galaxies show that creation and destruction coexist, keeping galaxies dynamic and ever-changing. Chapter 86. Certain galaxies exhibit warped disks from gravitational interactions or mergers. These distortions affect star and gas distribution, influencing star formation patterns. Warped galaxies illustrate that cosmic structures are rarely perfect. Gravity constantly molds them into diverse, fascinating shapes, shaping evolution over billions of years. Chapter 87. Galaxies sometimes host luminous stellar streams, remnants of disrupted satellites. These streams trace past mergers and interactions, acting as historical records. Studying them reveals how galaxies grow by consuming companions. Each stream is a story written in starlight, documenting destruction and renewal across cosmic time. Chapter 88. Some galaxies emit X-rays, revealing hot gas, supernova remnants, or black hole activity. High-energy emissions uncover violent processes hidden in optical light. X-ray astronomy shows that galaxies are far more energetic than they appear, allowing scientists to study the unseen power shaping these cosmic systems. Chapter 89. Certain galaxies contain ultra-compact dwarfs, tiny yet densely packed with stars. Orbiting larger hosts, they are relics of ancient mergers. Despite their small size, they reveal the history of galaxy formation and evolution. These compact galaxies remind us that even the smallest systems carry profound cosmic significance. Chapter 90. Some galaxies host massive radio jets emitted by central black holes. These jets extend thousands of light years, affecting surrounding gas and star formation. Radio observations uncover hidden energy and activity, showing that galaxies can harbor immense power invisible in visible light. Even calm-looking galaxies may contain dramatic forces driving their evolution. Chapter 91. Some galaxies contain dual or multiple nuclei from past mergers. Each core may harbor a supermassive black hole, slowly orbiting or merging over time. Studying these systems helps astronomers understand galaxy evolution and central dynamics. Hidden at the heart, these nuclei quietly orchestrate the fate of their galaxies across billions of years. Chapter 92. Certain galaxies are ultra-diffuse, with stars sparsely spread over enormous regions. Despite their size, they contain surprisingly few stars, held together by massive dark matter halos. These ghostly giants challenge conventional galaxy formation theories, revealing that the universe is filled with mysterious, nearly invisible structures. Chapter 93. Some galaxies form striking rings of stars and gas after collisions or tidal interactions. These rings spark bursts of star formation and shine brilliantly in blue. Ring galaxies are cosmic evidence that violent encounters can produce elegant and organized patterns, transforming chaos into beauty across space. Chapter 94. Galaxies sometimes eject enormous amounts of gas through outflows powered by black holes or starbursts. These winds regulate star formation and distribute heavy elements, influencing nearby galaxies. Observing them shows that galaxies are interactive, shaping not only themselves but their surroundings through powerful cosmic feedback. Chapter 95. Certain dwarf galaxies orbit larger hosts, subtly affecting their structure. These satellites can trigger waves of star formation in the main galaxy, showing that even small companions wield influence. Studying dwarf galaxies reveals how interactions, gravity, and proximity shape galactic evolution over billions of years. Chapter 96. Some galaxies spin at extreme speeds, with stars orbiting hundreds of kilometers per second. Dark matter is crucial to hold them together. Rotation curves reveal this invisible mass, highlighting that much of a galaxy's stability comes from forces unseen by the human eye. Motion itself unveils hidden cosmic architecture. Chapter 97. Galaxies host giant molecular clouds, the raw material for star formation. These clouds are shaped by stellar winds, radiation, and supernovae, creating chaotic nurseries where new stars ignite. Observing them provides insight into how galaxies constantly renew themselves, maintaining a cycle of birth and transformation over cosmic time. Chapter 98. Some galaxies glow in ultraviolet light, exposing hidden regions of star formation. UV observations reveal energetic processes concealed by dust in visible light. These nurseries demonstrate that galaxies are continuously renewing, with young stars emerging to shape their surroundings, keeping the cosmic story alive and dynamic. Chapter 99. Certain galaxies host massive star clusters orbiting their halos. These clusters are relics of the early universe, preserving chemical signatures from billions of years ago. Studying them allows astronomers to trace a galaxy's formation history. Even small clusters hold deep cosmic information, connecting present-day galaxies to the universe's origins. Chapter 100. Galaxies often exist in clusters, gravitationally bound cities of hundreds or thousands of galaxies. Interactions, mergers, and dark matter halos govern their evolution. Studying clusters reveals the universe's large-scale structure, showing that every galaxy is part of a vast, interconnected web, constantly interacting, colliding, and evolving over billions of years. That's 100 incredible facts about galaxies, each one a glimpse into the universe's endless mysteries. Remember, every star, cloud, and black hole tells a story billions of years in the making. Keep looking up, because the cosmos always has more secrets waiting to be